All right, welcome to this chapter of your lecture, focus on differential equations. And there are a few things that you have to know when it comes to differential equations. You have to know the order of a differential equation, which is basically the highest derivative in that equation. You also have to know whether the differential equation is linear or non-linear, as well as you have to know what is an homogeneous and a non-homogeneous, the difference between homogeneous and non-homogeneous equations. And probably lastly, when the equation is a function of one variable or two variables. So when it's one variable, we talk about ordinary differential equation. And when it's a function of more than one variable, we talk about partial differential equation, okay? So we have different methods and we have different type of differential equation. So in the first example, I want us to focus in the case of separable differential equation. Differential, DE means differential equation, okay? That's the short notation I'll be using in this video. If you are giving the following, f times x, f of x times g of x. To approach the separable DE, we want to make sure that we have y on one side only and x on the other side, okay? So to do that, if we want to divide this equation by g of y, we obtain 1 over g of y times dy over dx. This is just the first step, okay? Second step, we still have x here. So to get rid of this x, dx, we multiply everything by dx. By doing that, we have 1 over g of y times dy is equal f of x times dx, okay? From here, it is easy to continue because, as I say, we have separated this variable. X is on this side and y is here. So this is just, we just have to integrate this and obtain the solution. Let me give you an example. Solve dy over dx equal x times square root of y, subject to y of 0 equal 0. So I want us to use what I just explained here to solve this question. So basically here you can see that we have x, y, and here we also have x and y. So we have to multiply in such a way that we only have y on one side and x on the other side, okay? So if we divide this by y, first step, it is 1 over square root of y dy over dx is equal x. Secondly, we multiply everything by dx. This is 1 over root y dy is equal x dx. All right, at this stage, we just have to integrate. If I integrate here, we integrate here. We have, this is 2 root of y is equal half of x squared plus a constant c, okay? Or you can still rearrange this in such a way that we have square root of y is, we have y is equal x squared over 4 plus k. All right, if you say y of 0, we can still square this. If you square this, then it will vanish. You square here. So if you take y of 0 is equal 0, this means that k is equal 0. And in this case, the solution is just y, square root of y is equal x squared over 4. If you square both sides, you have y is equal x to the power 4 over 16. So this is the solution. Okay, so this is all about the separable differential equation. Now let's look at the exact differential equation. All right, exact DE requires a partial derivative, and the general form of this exact DE is m of x y plus n of x y dy over dx is equal 0. And we say that if you want, we call this equation 1. This differential equation 1 is exact if the following condition is satisfied. if the partial derivative of m with respect to y is the partial derivative of n with respect to x. So this is partial derivative, okay? This means partial. Partial. And it is different. We use this partial when you have more than one variable, okay? So when you have only one variable, we generally use the total derivative. The total derivative is this. Total derivative with respect to x is this, while partial derivative with respect to x is this. This is partial. Okay? So this is called partial, and this one is called total. Total derivative. All right. We have to check that this condition is satisfied before we conclude that an equation is an exact DE. Okay? And once we know that the equation is an exact DE, we are confident that we have to solve. And to do that, we look for a potential function. Here, I'll call it capital F, such that the derivative of capital F with respect to this, the partial derivative of F is equal m, and the partial derivative of F with respect to y should be n. This is a step to solve this, okay? Once we have this and this, then we can just integrate to obtain f of x, y is equal to the integral of m. M is also a function of x, y times dx, okay? The same is also applied for this second part. So you have f of x, y is the integral of n dy. All right. Finally, you just have to reconcile these two expressions to obtain the final expression for f of x, y. Because remember, when you integrate this with respect to x, the constant will be a function of y. And when you integrate this with respect to y, the constant will appear and will be a function of x. We will see that in the next example. So let's take this example. Example of separable DE. Solve the following differential equation. So here we are required to solve the following differential equation. So the first step here is to identify what is m. Here is m and n. So this is m of xy, and this side is n of xy, okay? First thing, as you see here, the method says that we have to check if the equation is exact. And that requires us to find the derivative. So I can write it like this. M of y is still mean the partial derivative of m with respect to y is, if we differentiate this with respect to y, we only have y here. This 0. So this will be 3x squared. Okay? And we also find the partial derivative of n with respect to x. If you differentiate this with respect to x, we have 3x squared. Conclusion, m, y is equal nx. Okay? Then this is an exact differential equation. Now let's use the method. We are looking now for the function f such that the partial differentiation of f with respect to x is equal m. We say f of x, y is equal the integral of m. This is 3 x y minus 2 dx. Yes, sorry, this is partial derivative is not the total derivative, okay? So this should be partial derivative. Remember that it's come from here, right? It's the same here, it should be partial derivative. All right, if you integrate this, we have the following. This is x to the power 3 times y minus, this is 6, so this should be 3 times x squared plus a function, let's call it this g of y, okay? Secondly, we still have to find f of xy, but now by using this second part, okay? So this is the integral of n of xy is, n of xy is this second part. So this is x cubed plus 2y partial derivative of this is dy. All right, if we integrate this, x, the first term is x cubed times y, and the second term is just y squared plus, let's say, h of x. Okay, so this is what we have. This is what we obtain, the first one and the second one. I want us then to reconcile these two functions in such a way that we can obtain the final function here. Because remember that we still have this g of y and h of x. Then to do that, you see we have this term is also here, okay? Here it does not appear, so it means this one, if I do this, is equivalent to this, and this one, if I just do this, is also equivalent to this term, okay? So this is here, this is this one, and this is this. So to reconcile, f of xy is x cubed y plus y squared minus 3x squared. All right, then the solution to this differential equation is the following. Remember that we have to get a constant, okay? In this, so this is x cubed y plus y squared minus 3x squared is equal a constant. So this is the solution to our differential equation, okay? All right, this is all for this video. It was only focused on the separable and the exact differential equation. So in the following videos, you will see how to use other methods to solve other type of differential equation, okay? That's all. Thank you.